Thank you for joining us today. At this segment of the Rambus Design Summit, we will take a look at the LPDDR5 solution offering from Rambus. I'm Vinitha Seevaratnam from the Interface IP unit at Rambus. So before we get into the LPDDR5X specifically, let us take a step back and recap on how this memory technology has evolved and how we have come to this fifth generation of LPDDR. Looking back over the recent history in the memory landscape, we can clearly see a trend of new applications growing significantly large enough to command the creation of new memory technologies to tailor to their specific needs. So we saw this with the creation of GDDR for graphics and later for HBM for AI ML applications. The LPDDR low power double data rate emerged as a specialized memory designed for mobile applications. And it was predominantly driven by higher performance and lower power consumptions for mobile devices. And we see that with each growth of LPDDR, the performance has increased to match the major shifts in mobile user experience, from social media to gaming, from 4K to 8K needs of video. So let's take a look at the LPDDR journey from LPDDR1 to LPDDR4X. LPDDR evolved from DDR memory technology, and over the course of its lifetime, the standard has advanced considerably to incorporate new features designed to meet the evolving needs of the mobile market. Now, LPDDR1 provided lower power consumption and improved performance compared to the traditional DDR memory. In 2009, LPDDR2 was released, and this delivered many new enhancements over the first generation of LPDDR. It offered advanced power management features, and it offered shared interface for non-volatile memory and volatile memories. And one of the key aspects is it also provided wider command buses to define the read, write, activate, and pre-charge. And then we see in 2012, LPDDR3 came into the marketplace with higher data rate, greater bandwidth, and also higher memory density as well. Now in 2014, LPDDR4X came into the marketplace, providing performance up to 4.266 gigabits per second. And so obviously this doubled the data rate, transfer rate. And one of the new architecture shift in this technology was it went from one channel with 16 bits per die to two-channel die with 16 bits for a total of 32 bits. So that is just a little bit of recap of our LPDDR journey up to LPDDR4X. And next, we will take a look at the LPDDR5 specifically. So this is the latest standard. It's a fifth generation standard, and it's the LPDDR5X with the extensions. And this can perform up to 8.533 gigabits per second, significantly boosting the speed and performance. And as you can see, it actually provides quite a bit of performance from the previous generation of LPDDR4, which was at 4.266 gigabits per second. Now, for the mobile memory marketplace and applications, due to the space considerations for mobile, combined with the greater memory needs for advanced applications, LPDDR5X can help achieve and capacities up to 64 gigabytes by using multiple DRAMs in a multi-die package. So with that, let's take a look at some of the applications that LPDDR5X could be useful for. So with its low power consumption and high bandwidth needs, capabilities, LPDDR5X is a great choice of memory, not just for cutting-edge mobile devices, but also for mobile-influenced applications such as AR, augmented reality, VR, virtual reality devices, as well as AI inference, where power efficiency and compact form factor are crucial considerations. So these are some of the applications, but obviously there are other applications as well where LPDDR5 could be used apart from the standard mobile use predominantly in the past. At this segment of the presentation, let's go ahead and look at Rambus's LPDDR5 solution offering and how we can help provide the LPDDR5 needs for your next designs. Rambus provides a comprehensive LPDDR5X solution offering to the marketplace. It is configurable to maximize performance and also minimize power. It's configurable because, as you can see, we can provide the LPDDR5 controller by itself, or we can provide it with some of these add-on cores that you see on this light blue box, where the AXI multi-port read modify can be optionally added to the LPDDR5 controller as needed. So based on your requirements, we will work with you to gather your requirements need and configure the solution so it's actually catered to your specific design needs. So by doing that, you're able to maximize the performance and also help minimize power as well. In addition to providing some of these add-on cores for your design, we also provide full design, test, and bring up challenges where we can help meet those needs as well. For that, we do provide a memory test package that includes a memory test and the mem test analyzer on the bottom there. And by utilizing this memory test package, you can actually isolate the memory subsystem from the rest of your design, and you can go ahead and verify your memory controller, the PHY, and the memory devices by itself, so you can assure that memory subsystem is fully functional based on what you would expect. So the memory test package is a useful add-on package that we provide for our customers as well. And in addition, it's fully validated. And when we provide this solution configured for your needs, we will provide it also with a complete reference design, as you see with the light blue box. And then this is provided as a soft IP on deliverables. Now, the interface between the memory controller and the memory PHY, it's based on a DFI 5.0 standard. So with that, let us dive next into the LPDDR5 controller features itself. So the LPDDR controller supports all of the standard LPDDR5X features. It supports all of the devices per the JEDEC specifications. All speed grids up to 8.5 gigabits per second per pin rate is supported. All densities, including up to 32 gigabit per channel support, is provided. And we offer all bank and single bank refresh, in addition to refresh management support. Power down mode and also support for by 16 and by 8 mode support is also offered. Now, sticking with our configurability offering to our customer base, we provide two different options of our controller. We call it the dual controller configuration and the single controller configuration. In a dual controller configuration, you will have two memory controllers interfacing to two of the memory channels of the memory device. So where the two memory channels are operating completely independently. So one of the memory controllers in that case will be interfacing to a 16-bit of the memory channel. Now, in a single controller configuration, you will have a single controller interfacing to the two memory channels simultaneously, and the two 16 bits of the memory channel in that case is combined to form a 32-bit interface to the memory controller. So you can choose either of those options based on your design needs. Now, the controller itself is going to be operating at full rate operation. So if you're hitting the maximum rates of 8.5 gigabits per second pin rate operation, that means your memory controller is running at 1.0 gigahertz. We do provide multi-channel operation support as well. And to hit maximum performance, the controller utilizes bank management, look ahead, and reordering. And as mentioned in the previous slide, you do have the option of the various add-on cores that you can add on to the memory controller, such as the AXI, multi-port, inline ECC. We will take a look at it on the next slide a little bit in detail, and the memory test support, we will also take a look at it a little bit in the upcoming slides. So these are add-on cores that you can choose to add if you needed those for your specific design needs. Now, in addition to providing all these add-on cores, when we make a delivery to our customers, we do provide it in addition along with a generic PHY model as well. And this is useful because this version of the delivery can be easily incorporated into the customer's design and be able to simulate pretty fast. So this is also something that we will provide when we make the deliveries as well. So let us go ahead next and take a look at the inline ECC support a little bit. So historically, we have used the out-of-band ECC support for design needs when ECC support was needed. However, in LPDDR5 case, you will see that it is not feasible. For the out-of-band ECC to work, say for instance, you have a 64-bit data, you would require 8-bit of ECC in that case to give you a total of 72 bits. And you would need an extra memory device for an out-of-band ECC. Now, with LPDDR5, the components are available in 32 and 16-bit versions. So you can't very efficiently create a 72 or a 36-bit memory to do out-of-band. So how the ECC is handled is by doing inline ECC, where the ECC itself is stored in the same memory as the data. So in this case, since it's inline, 8/9 of the segment is used for the data, and then 1/9 of the segment is used for the ECC. And since you're using the same memory as the data for the ECC, you will see a little bit of a performance impact. However, we will work with you to assure that you configured the configuration is maximized and is configured accordingly, so this performance impact is minimal. And then we also do provide partial inline support as well, where in those cases it removes the inline ECC overhead for graphics or other non-critical data. So with that, let us go ahead and take a look at the memory test support that we offer as part of our solution offering. As we previously talked about, we do provide a pretty comprehensive memory test support to help our customers in the bring up phase of their design. And we do, as part of the memory test support, provide some of the basic writes and reads to capture discrepancies, and it supports random sequential arbitrary addressing, and also it supports walking ones, zeros, counting random arbitrary data as well. But in addition to all this, Rambus also offers an advanced memory test support as well, where we have created a microsequencer that can generate complex patterns for to analyze production or field test failures. This does come with some example algorithms that we provide, such as March, Galpet, Down, and this can be a very useful tool for our customers, and we have seen our customers utilize these tools in some of the advanced technology needs. Now, the programs are executed out of RAM, and this is something that is also available as a memory test support. In addition, we also do have something called the memory test analyzer as well, that you can reach out to us and we can provide more information on that. So with that, we will go ahead and summarize this presentation a bit. So we saw that with the evolution of LPDDR, it was predominantly driven by the need for high performance and lower power consumptions in mobile devices. However, with this lower power consumption and high bandwidth capabilities, we see that this technology is not only used for mobile devices, but also for some of the other applications like you saw in AR, VR, and also useful in AI inferences as well. And we see the LPDDR5X being a great choice for some of those application needs, where power efficiency and compact form factors might be crucial consideration for your design needs. And Rambus provides a very comprehensive LPDDR5X memory solution to the marketplace. So if your next design needs require an LPDDR5X solution, please do come talk to us, and we'll be happy to talk to you further and make sure that we are helping you with your next design needs. Thank you so much, and enjoy the rest of the presentations.